In this video, I'm going to show you two properties for exponents when you have fractions. And so I want to talk about the quotient of powers property and then power to a quotient, meaning fraction taken to a power itself. So with these two rules, what I want to do is just kind of explain them at first. And so what I'm going to do is write out that if you had x to the fifth, it would really be the same as 5 x's being multiplied together. And x to the third is the same as 3 x's being multiplied together. And based off of division properties, if you multiply and divide by something, or if your fraction is, something over itself, it cancels out. And so what I'm left with is 2 x's in the numerator. And quickly, more simply, all you would need to do is take your 5 and subtract your 3, and you get your x to the second power. So our operation here is a subtract. And here our rule is going to be, if we have two exponents with letters that we don't know what they are, that rule about subtracting is what we really want here. So if we have the same base and those same bases are raised to a power, you subtract the powers. You subtract the exponents. And then power of a quotient here, this is when you have a quotient, a fraction, that's what that means, fraction to a power. What you want to do is distribute your fraction, distribute your exponent to every part of the fraction. So we're going to distribute that square to the 2 and to the 3 on our fraction. So I'm going to write distribute. So if I take 2 times 2, I get 4. 3 times 3, I get 9. And this would be the answer to that question here. This one was x squared. And again, like I said, distribute here. We'll have a to the m and our different base b also to the m. So distribute. To find a power of a quotient, find the power of the numerator and the power of the denominator, and then divide if you can. And those are our two rules. In the next couple videos, you'll see examples of each of those two properties. So stay tuned.